So this is section 4.5, graphing logarithmic functions. And we're going to do a quick little dive into the properties of logarithmic functions. The first one is, the domain is a set of all positive real numbers, and a range is a set of all real numbers. So that means, in this case, it's the opposite of the exponential. So we know our range is going to be negative infinity to positive infinity. And the second thing, so this is number one, the second thing is that there's no y-intercept. The x-intercept is 1, 0. So x-intercept is 1, 0. And the last one is the graph contains the points 1 over a, negative 1. So our first point will be this. Our second point will be this. And our third point will be this. So this is what we'll use when we're setting up for the toolkit function. So let's do a couple of examples of this. So let's do f of x equals log base 2. Let's do x plus 2 plus 3. Okay, so let's first set up using these points that they gave us. So what is our a? Well, our a, we know in logarithmic functions that our 2, or our base number, is what corresponds to a. So that's what we'll use to set up our chart. So if it's 1 over a, 1 over 2 is 1/2, negative 1, 1, 0, and then it's going to be 2, 1. Now, if it was a different base, then you would use the value that's there for a. But since it's 2, we're using 2 here. So we're going to graph out our toolkit function. So our toolkit is f of x equals log base 2 of x. So now I'm just going to graph here. So I'm going to pause it and graph it for you guys. Okay, so I've drawn the graph for you guys and labeled our points. So all I did was just use the points we found. And now we can do the next step. So what is that? The next step is going to be this guy right here, the x. So that's going to be our horizontal shift. Now whatever is there, we're going to do the opposite. So if it's plus 2, that means we're going to go to the left 2. If it was minus 2, we go to the right 2. This is going back to the exponential graphing we did in the last video. So now let's graph this. So now I'm going to write the horizontal shift here. And this is our first transformation. Okay, so if I want to move left 2, I'm going to look at 1, 0. So if I move that left 2, that means it's going to go to 0, then negative 1. So it's going to be negative 1, 0. What about the one above that? Let's do that one next. So it's 2. 2, move left. So it'll be 1, and then I'll be 0. 0, 1. So let me do a dash there. Now, the bottommost one is 1/2. So let's see, if I move that, I want to move that. a 2 over. So if I subtract from 0.5 minus 2, I get 1.5. Negative 1.5 though. So 1.5, it's going to be right about here. And that was on negative 1. So all we did is we shifted our points to the left since it's positive 2. So now let's draw our line. Okay, now let's label our points. I just changed this to a decimal to make it easier for myself. Okay. And this is 0, 1. Okay, so this was left 2, horizontal transformation. Now let's do our last graph. So our last graph is going to be vertical transformation. So it means everything's going to move up 3. So let's draw that. So if I look at my first point, I'm going to do the negative 1, 0. So if we're going up 3, if it's on 0 right now, it's going to want to go to 3 then. And make sure it stays on the negative 1. So now it's negative 1, 3. What about 0, 1? Okay, so we're on 0. It's on 1, so now it's going to want to go up 3 from that. So 1 plus 3 gives us 4. So now that one's going to be here. And then if I have negative 1 plus 3, so negative 1 plus 3 gives me 2. So now we're on negative 1.5 still. And now we're on 2. Okay, so change the color on these, and now we have our final graph. So now our question is, okay, what is the equation of the asymptote? So if we know that, let's look at the original equation, right? So we had x plus 2, and we know the x plus 2 landed up on going to the left 2, so we know that now our x is minus 2. So we know our equation is x equals minus 2. So you notice also with the logarithmic, we're looking at the x values versus on the exponential, we're looking at the y values. Now the domain is going to have, and it's going to be based on what we got in the asymptote. Versus the range, we know the range, we said earlier, that we know that the range is all real numbers. So that means it's going to be negative infinity to positive infinity. And the domain is based on what we found. So from left to right, so I'm going to write negative 2 to infinity. Okay. Okay, so let's do one more, and this will give you an opportunity to practice. Let's do these two. let's actually do minus. Okay, so I'll try this one. So pause the video at this point and then come back and see if you can get the answer. So this next part, I'm just gonna write down each step and then talk through it. Okay, so I have drawn out each of the steps. So we make our chart, and since we have a base of 2, that becomes our A, so it's 1/2 and 2 in the chart for X. Then we draw our initial graph. You notice it's the same as the last graph that we had. And since it was the same base. And then the next step is to do our horizontal shift or horizontal transformation. So that's the X minus 3. And since it's minus 3, that means we're going to go to the right 3, so the opposite of the sign. So in the second graph, I did the first transformation here to the right 3 and wrote out my function. And you can see all my points have moved. So if I was on 1, 0 originally, I've moved to the left 3. So that means 1 plus 3 is 4. And then let's say for the 2, 1, 2 plus 3 is 5. And then 1/2 plus 3 is 3.5. So all I did was move our X values. Now, the next one was to do our vertical transformation. That means we're decreasing by 2. So I look at my original points, and I did 5 and 1, so I did the Y. So 1 minus 2 is minus 1. 0 minus 2 is minus 3. Negative 1 minus 2 is negative 4. And all the X values are still the same. So all I did was go down 2 for my second transformation. So now, what is our asymptote? So our asymptote is based on where we left off. So this is an X, not a Y, an X of 3. So our equation for asymptote is X equals 3. Our domain and range. Our range is, again, all real numbers. And our domain is from left to right. So it's 3 bracket to infinity, parenthesis. So that is how you graph logarithmic functions.